Okay, so we're going to solve the following three integrals. So we're told x is equal to 4 cos of t, y is equal to 4 sine of t, and we're confined by the following. So let's first solve this first integral. So let's plug in xy. So it'll be 4 cos of t times 16 sine square of t, and then differentiate d of x. So it'll be minus 4 sine t dt. Alright, and we're integrating from 0 to pi over 2 because that's the range for t. And this gives us minus 256 sine 3t cos t dt. Cos is the derivative of sine, so let's bring out the minus 256 out in the front, and then you just have to integrate sine 3t times cos t dt. And the integration of this is pretty easy. It's just sine 4t over 4, and we're integrating from pi over 2 to 0. And this would give us minus 64. Now for part B, it's the same integral, but we're integrating with respect to d of y. So let's just plug in everything again. So it's 4 cos of t, 16 sine squared t times differentiate y. So 4 sine t differentiated, that's 4 cos t dt. Okay, and let's combine everything. So that's 256 cos squared of t sine squared of t dt, and then we can bring the 256 out in the front. So now let's integrate cos squared t sine squared t. So if you recall, sine 2 of t is equal to 2 sine t times cos t. So if we were to square everything, this would be 4 sine 2t cos 2t divided by 1 over 4. Okay, and this and this match. So what we can do is rewrite this as the following. Okay, and now we have to still integrate this. So recall the next one. So cos 2t is equal to 1 minus 2. So I'm going to actually just call it x. Cos 2x is equal to 1 minus 2 sine squared x. Let's rearrange. Okay. Now, what we're going to do is times this by 1 over 8. So this is 1 over 4 sine 2x is equal to 1 over cos 2x all over 8. Okay? And we can just plug this into here. So it'll be 256 1 over 8 minus 1 over 8 cos 2t dt. Okay? Now let's take out the 1 over 8. So we'll just put it here. And 256 over 8, that's 32. Now we can just integrate this, and that would give us the following. Okay? Okay, looks pretty good. Oh, wait, sorry, there's a small mistake. This is 1 over 4 sine squared t. We had 1 over 4 sine squared t times 2 of t. So we should let x equal to t. So it would be actually the following. Okay? Sorry. So that was my mistake. So this should be just 4t. And I think I did the integral correctly. So I think it should be like that. Yep. Okay. And that'll be pi over 2, 0. And that gives you 16 pi. Okay? Now let's do the last one. Now we will have to do part C. So for part C, it's integrating x y squared ds. So we have to find a way to plug in for ds. So ds will pretty much be equal to the derivative of x to the power of 2 plus the derivative of y to the power of 2 d of t at the end. Okay, so it's going to be, so we know x is equal to 4 cos of t, y is equal to 4 sine of t. So it's going to be the derivative of 4 cos of t squared plus the derivative of 4 sine of t squared dt. Okay, so wait, I think we found the derivative for first and then square it. My bad. Yeah. Okay. So that's gonna be 4 sine minus 4 sine of t squared plus 4 cos of t squared d of t, and that's gonna give you 16 sine squared t plus 16 cos squared t dt. Okay, and that's just, we can factor the 16, and sine squared t plus cos squared t, that's just 1. So it's just going to be 4 dt, and we can just plug in that 4 into there. So we now have integral of 4 cos of t times 16 sine squared t times 4 dt. So that's 256 sine squared t cos of t dt. Alright, and recall cos is the derivative of sine, so it'll be sine 3t over 3. Oh yeah, and then we're integrating from 0 to pi over 2. And our answer should be 256 over 3. Okay, so that's your final answer.